So today we're looking at chapters 3 and 4 in review. So chapters 3 and 4, we start to look at regression analysis. Okay, so we're looking at association between two variables essentially, how their relationship can be explained. So right at the start of chapter 3, we're looking at different types of data, categorical data compared and numerical data combined. So here we've got some box plots with some categorical data, the categories of the ages, and some numerical data with the salaries along the bottom on a number line. Okay, so when we have two variables, we have one is a response variable and one is the explanatory variable. So the explanatory variable depends upon the response variable. Okay, so the explanatory variable is generally the y and the response variable is generally the x. Okay, and when we plot the data. Okay, so let's have a look at these box plots and the type of thing we'd expect in a report. Okay, so it's the people's salary at different ages, and what we can see here is if we're looking at comparing the medians, as age groups increase, the median salary increases as well. Okay, so we're looking at the median salary here, and you can see it moves along this number line as the age groups increase. So there's a trend there. The other thing we can compare is the interquartile ranges. So the interquartile range is given by the box in the box plot. So we can see what's happening here is the box is getting wider as we go to each age group. Okay, so what that means is that there's a bigger spread of salaries in the middle 50% as we increase each age group. Also with the range from the end of the box to the other end of the box, from the bottom to the top, is getting bigger each time as well. And when we start to get to 40 plus, we start to get outliers. So some people whose wage is much bigger than the rest, and particularly in older people. So they'll be CEOs of companies and things like that. And the other thing we're going to compare is we want to compare the shape. So this one here is very, very positively skewed, which means it's concentrated down the bottom end and then it tails off at the top end, at the higher wages. Whereas that compared to the 20 to 29 year olds, that's very, very symmetrical. And the 30 to 39 year olds are roughly symmetrical as well. A little bit of a tail in the top 25%. And we can see that skewing increases as we go along. So there's some of the things you would explain if you're comparing some box plots. Okay, and it's got the book descriptions written down here, which you can pause and read in detail if you wish to. Okay, so when we're looking at two numerical variables, which is what we're going to be mostly doing in this topic, we want to start off by looking at a scatter plot. Okay, but they both have to be numerical variables for us to look at a scatter plot. Okay, so here we've got hours worked and participation rate. Okay, and let's just go back here and fix up my error. So let's just fix this one up, and this is the thing you have to be very careful of. So the response variable is the y variable and the explanatory variable is the x variable. And to those people who picked that up, well done. Those people who didn't, just be very careful with that. It's easy to make that mistake. So the response, we're responding, y equals something to do with x, and x explains what's happening. So y depends on x. Okay, so RV depends on EV. Y depends on x. Okay, so in our scatter plot, here we've got the response variable is hours worked. And number of hours worked depends upon the participation rate in the workforce. Okay, and I'm just getting to the point. So it's actually university participation rate. So what percent of people went to university, and it's across 9 countries. Okay, so we've got a scatter plot, and we can see the scatter plot's got a shape. It's roughly linear. We could probably see a tiny curve in there. Don't know, unless it's an outlier. We'd want to check if that was an outlier. It's got a negative slope. So as the participation rate increases, hours worked decreases. Okay, and you need to be able to construct a scatter plot using your CAS. Okay, I'm not going to go into it in detail here. What you need to do if you're not sure, if you want to, actually, it's not a bad idea just to pause this video right now and go to page 104 of the textbook and just go through that exercise. It'll take you a couple of minutes. Go through that exercise of putting the data into the spreadsheet on your CAS and constructing the scatter plot. Do it now, just to refresh your memory about how to do it. So it's page 104 of the book. Pause the video and then join me on the other side once you're happy you know how to create that scatter plot. Okay, welcome back, and now we want to just interpret what the scatter plot means. Okay, so the things we're going to look for is the direction and any outliers. So the direction, we can have a positive direction sloping upwards, a negative direction, or it could be flat. It doesn't have to have positive or negative direction. We're going to look at the form, whether the data is linear, which is what we want, or whether it's curved. Okay, and we're going to look at correlation. So correlation can go between -1. -1 would be perfectly negative slope, so all the points lined up in a perfectly straight line sloping downwards, and +1 would be all the points lined up in a perfectly straight line sloping upwards, and everything in between are just all the different variations. Okay, if the R is 0, that means it's got no correlation whatsoever. We can't see a trend. So this one, it's got a correlation of -0.7. Okay, so it's going downwards. And if we look on our table here, -0.7, so we would say that was a moderate negative association. Okay, so that one there, moderate negative. And I've just gone over the top of the other one. So this one's got a correlation of 0.5. Okay, so you can see they're further apart. So it's 0.5, it's positive, it's sloping upwards. And so a correlation of 0.5 would be a weak positive correlation. Okay, so weak positive. This one, they're even a little bit more scattered and starting to not quite see so much trend. It's sloping downwards. So it's got a negative correlation, and this one is 0.3. So negative 0.3 is also, it's going to be a weak negative correlation. Okay, if it was much smaller, it was between -0.24 and 0.24, then we start to say there's no association. So it's not far off that. And this one here is an R equals +0.9. It's got a strong positive correlation. Okay. Once again, in your textbook, it tells you how to actually go and calculate the correlation, and that's on page 114 of your textbook. How to calculate correlation coefficient using a TI-Nspire CAS. It's about half a page. Once again, there's a little exercise there. Pause the video, go to page 114, put the data in, and make sure you know how to work out the correlation. Particularly do this one. This was something that people weren't very good at when we did the SAC. Okay, so pause the video now, go and have a go at that exercise on page 114. I'll see you on the other side. Okay, once we've got the correlation coefficient, which is R, then we're going to square it. Okay, so remember, R can go between -1 and +1. When we square it, all the negatives become positives. So then, when we square it, R squared is between 0 and 1. Okay. and it gives us the coefficient of determination. It tells us how much of one variable can be predicted from another. So say we've got an R squared value of 0.64, that's the same as 64%. And what we're going to say there is the coefficient of determination tells us that 64% of the variation in people's weights is explained by the variation in their height. That is the standard sentence. Okay? If you have to explain anywhere at all, if you have to explain correlation, a coefficient of determination, that is a standard sentence that you use. Okay, you change that number, you'll change the variables, but that's all. So 64% of the variation in people's weights is explained by the variation in their height. Okay, it's telling us how much, how good that relationship is. Okay. So then we move on to chapter 4 and we start looking at a least squares regression line. Okay, so once again, how to do it on the CAS is explained on page 136 to 137 in a box with some data, and the data that they're using is this data here. So basically we get the data and we've got our X variable which is we've got our X variable and we've got our Y variable. We put them into a list and a spreadsheet on our CAS. So our X's are the heights, our Y's are the weights. List them down. Make sure that if they're together here, 177 and 74, that are together there. 178 and 63, that they're together. Okay. Then we go through the process, and I want you to actually pause the video and go through the process. So pause it now, and when you come back, I'm going to explain your results. Okay, so use the data, go and put it into the spreadsheet, get your scatter plot, and just go through the steps on pages 136 and 137. Okay, welcome back. So you hopefully got what we've got down there. So you've got a scatter plot that is positive. We've got a least squares regression line fitted to it. Our R squared value is 0.723 or 72.3%. It asks you in the question to do it to 3 significant figures, so 1, 2, 3 significant figures. The 0 is not significant. And we get this regression line. Once again, 3 significant figures and 3 significant figures. So y equals minus 84.8 plus 0.867x. Then what we're going to do is we just use x and y to do the regression, but we're going to replace that with what the x and y actually mean. So the y means the weight, so the weight equals minus 84.8 plus 0.6867 times, and x equals a height. So this has got a meaningful relationship. That is how we calculate someone's height, someone's weight given their height. On average, it's not going to work for everyone. You can see that. It's going to give the average. This person, it's not going to work for. It's a little bit out. There's a residual there. This person, it's a little bit under. Okay, so but that's an average. So when we do a regression analysis, and that's basically what the rest of the chapter is, a chapter from 4C onwards looks at. When we do a regression analysis, we do these things. We draw a scatter plot. We fit our line of best fit to the data, our least squares regression line. Then we need to interpret the slope and the intercept. Okay, so y equals a plus b x. Okay, that's the intercept. That will give us the slope. If this number here, if this has got a plus in there, then it's sloping upwards. So it's a positive relationship. As one thing increases, the other increases. If it's got a minus in there, it's a negative relationship. So it's one variable decreases, the other increases. Okay, and once we're happy, we've got a good, we looked at our correlation, so we look at our R-square value, so we can explain, see how much is explained, and if it's significant, then we can use our data to make predictions. Okay, so we can use our line, so we can put a value in for X and get a value for Y, and that's an average prediction. If we're predicting within the range, so let's go back and see what that means. So this range of X values goes from, what's the smallest? It goes from 162 up to 184. Okay, so these range of values. So if we make a prediction between 162 and 184, that is an interpolation. Okay, so that's an interpolation because it's within the range of data. If we go less than, say we want to predict for someone that's 140 centimetres or someone that's 205 centimetres, that would be outside the range of data, and that would be an extrapolation. With extrapolation, we have no way of knowing whether our prediction is variable or not. So we might have some data that looks like that. It's perfectly straight. But what might happen is outside, it might tail off. If we're looking at the heights of children, children grow quite uniformly, but they reach an age where they stop growing. Okay, so it tails off. So if we make predictions that are extrapolations, that mightn't be a very good prediction. Okay, we're probably going to predict that the person is going to be 3 metres tall when they're 27, which doesn't make any sense. It's a nonsense that's because it's an extrapolation. It's outside the data range that we have. Okay, so that's a regression analysis. The other thing I spoke about before is residuals. So each data point is the blue dots, the regression line is the red line, and each deviation from the regression line, each vertical deviation from the regression line is a residual. So the residual value is the actual value minus the predicted value. So here, the residual will be negative because it's this value minus the predicted value there. So it's a small value minus a bigger value, it will be negative. This one here, the residual, both of these, the residual will be positive. This will be smaller and this will be bigger. Okay, because it's the actual minus predicted. Actual minus predicted. Okay, so data points above the regression line have a positive residual, all these ones. Data points below the regression line have a negative residual, and if one falls exactly on the line, none do, this is close, they'll have a 0 residual. Okay, so we've got scatter plot for the value of a 6-year-old car. So a 6-year-old car on the scatter plot, the prediction is it's going to be about $12,000. Okay, and the actual value, it's about $7,000. So it's about, the residual is negative $5,000. Okay, so that's the residual. The 7,000 minus the 12,000. The actual minus predicted. So 7,000 minus the 12,000 gives us minus $5,000 for the residual. So they're residuals. So that's a summary, a very brief summary of chapters 3 and 4. What I want you to do for the rest of the day is just go through review questions from both chapters 3 and 4. Make sure you're using your CAS, you understand how to use it. Just refresh yourself about how to do everything that you needed to do in the first SAC. Okay, all the best with that. If you need to ask a question, I'm on Teams chat. Just come in and ask me a question and I'll help you with it. Okay. The more questions you do in review, the more you're going to trigger all your memories of what you learned earlier in the year. So go and have a good review, and let's get ready for those exams.